Welcome to Section 8, Lesson 2. Lesson 1 pulled out the greatest common factor when one existed. Today's lesson is for polynomials that do not have a single monomial GCF but still factor cleanly through a different mechanism. Factoring by grouping is the technique, and it is the standard move on any four-term polynomial. Factoring by grouping works on a polynomial with exactly four terms when those terms do not share a single monomial GCF. The strategy is to split the four terms into two pairs, factor each pair separately, and discover that both pairs leave the same binomial in parentheses. That shared binomial is the common factor we pull out front. The mechanics are straightforward, but the signs matter. The first pair usually factors out a monomial that contains the variable. The second pair factors out a constant or smaller monomial. The trick is to choose those factorizations so the leftover binomials match exactly, and that sometimes means factoring out a negative when the second pair has a leading minus sign. Today's two examples cover the clean case and the sign flip case. Once both are familiar, every four-term polynomial in this section is in reach, and the same idea sets up the upcoming trinomial with leading coefficient lessons that depend on splitting the middle term. Let us walk through the procedure on a clean example. The polynomial is x cubed plus 2x squared plus 3x plus 6. Four terms, no obvious monomial that divides all four. The standard move on a four-term polynomial is grouping. Split the four terms into two pairs by parentheses. The first pair takes the first two terms, the second pair takes the last two. So we have x cubed plus 2x squared inside the first set of parentheses, and 3x plus 6 inside the second. Factor each pair separately. The first pair has a common factor of x squared, leaving x plus 2. The second pair has a common factor of 3, leaving x plus 2 as well. Both pairs left the same binomial x plus 2, which is exactly what we want. Pull out the common binomial. The polynomial equals x plus 2 times the quantity x squared plus 3. Two binomial factors instead of four scattered terms. That is the entire grouping technique in three-move split. Factor each pair, pull out the shared binomial. Example 1. Factor 6x cubed minus 9x squared plus 4x minus 6. Four terms again, but the coefficients are larger, so the pair factorizations need a bit more care than the concept example. Split into two pairs. The first pair is 6x cubed minus 9x squared. The second pair is 4x minus 6. The plus sign between the two parenthesized groups stays positive, so we do not have to worry about a sign flip on this one. Factor each pair. The first pair has a common factor of 3x squared. 6x cubed divided by 3x squared is 2x. Negative 9x squared divided by 3x squared is negative 3. So the first pair becomes 3x squared times the binomial 2x minus 3. The second pair has a common factor of 2. 4x divided by 2 is 2x. Negative 6 divided by 2 is negative 3. So the second pair becomes 2 times 2x minus 3. Both pairs left the binomial 2x minus 3. Pull out the shared binomial. The polynomial equals 2x minus 3 times the quantity 3x squared plus 2. The factorization is complete in 3 lines of work, and you can verify by multiplying back out and recovering the original four terms. Example 2. Factor 2x cubed minus x squared minus 6x plus 3. Four terms, but this time the second pair leads with a negative coefficient. That changes how we factor the second pair without changing the overall procedure. Split into pairs the usual way. The first pair is 2x cubed minus x squared. The second pair is negative 6x plus 3. The leading minus sign on the second pair is the signal that we will need to factor a negative out, otherwise the binomials will not match. Factor the first pair x squared times the binomial 2x minus 1. For the second pair, factor out negative 3. Negative 6x divided by negative 3 is 2x. 3 divided by negative 3 is negative 1. So the second pair becomes negative 3 times 2x minus 1. Both pairs now share the binomial 2x minus 1. The shared binomial is 2x minus 1. we can rewrite the second pair as -3 times 2x minus 1, which makes the shared structure obvious. Pulling that binomial out front is exactly the same step as in the clean example. The factored form is 2x minus 1 times the quantity x squared minus 3. Notice the negative carried through cleanly because we chose to factor a -3 from the second pair. That is the entire negative sign trick. When the second pair leads with a minus, factor out the negative so the binomials match. 3 takeaways for factoring by grouping. Each one cuts decision time when you face a new 4-term polynomial. Factoring by grouping is the right move whenever you see a polynomial with exactly 4 terms and no single monomial divides all of them. The 4-term shape is the trigger to reach for grouping rather than continuing to scan for a missing common factor. The mechanics are split, factor, share. Split the 4 terms into 2 pairs. Factor a common factor from each pair separately. The 2 pairs must leave the same binomial in their parentheses. That shared binomial is the answer's first factor. What is left out front is the second. When the second pair starts with a negative, factor out a negative number from that pair. That sign flip is what lets the second binomial match the first. If you try to factor a positive number from a pair that starts negative, the leftover binomial would have flipped signs and the grouping would fail.